Hi everyone, and you are welcome to this lecture, Python lists. In this lecture, we are going to learn about another collection in Python, which is list. So I'm going to define what a list is. We will see how we can create a list. We will see the operators that can be used with lists. We will learn how we can access to list contents using indexing and using list slicing. And as usual, I'm going to end up this lecture by a quick summary. So let's get started. First, let's define what a list is. List is one of the most important and useful data structure, which represent a sequence of items. And these items could be number, string, another list, or any other object supported in Python. To understand the Python list better, let's first see its attributes. First of all, the syntax. In order to create a list, we have to use a square bracket. And you have to know that list is an ordered data structure, which means each item has its own known and fixed location. List is immutable, so once you create, you can update the content of the list. List is an indexed data structure, so you can get access to each individual item inside this list by using integer indexes, and the indexes could be positive or negative. And the last point, you have to know that lists support slicing, so you are able to extract a sublist from your list using also positive and negative indexes inside the slicing operator. Now let's move to PyCharm IDE to see some practical examples about Python lists. First of all, let's talk how we can create a list. Let me define a variable, its name a equal to. To create a list in Python, you have to use square bracket, and as you see here, I open and close a square bracket. Then you have to put items like 4, 5, 6, C for example, and so on. And as you see, I separate between each two items by using a comma. Now, if I print A and if I print the type of A, you will see my list is 4, 5, 6, C, and the type is list. And as you can see, you can put any data type here as an item. So I choose to put in this case integer, number, and string. So there is no problem, you can put any type. Now let's talk about operators that can be used with list. Let me assume that I have the following two lists. List 1, which is 1, 2, 3. List 2, which is 4, 5, 6. The first operator that I want to talk about is concatenation. So let me say concat equal to list 1 plus list 2. When I use plus sign between two lists, this means concatenation, which means combine the two lists together. And as you see, when I print concat, I will get a new list which has all the items of the two lists that I used for this operator. Also, you have to know that lists support concat and assign. So if I put plus equal and then I say list 2, this means concat list 2 with list 1 and then assign the result to list 1. So if I print list 1 now, I will see all of the items from list 1 itself and from list 2, and the result has been assigned to list 1. So list 1 now, it's a new list, contains all the items. And that's all about concatenation. Now let's see repetition. For the same two lists, first of all, I will say rep equal to list 1 multiplied by 5. And then I will print rep run. As you see, when I use asterisk operator with list and an integer here, you will note that my list has been repeated for 5 times. So asterisk in context of list is a repetition operator. Also, you have to know that lists support repetition and assign. So if I say list 1 asterisk equal 5 and then I print list 1, you will see that list 1 has been repeated for 5 times and the result after the repetition has been assigned to list 1 again, and I got this result. And that's all for list repetition. Now let's talk about membership operators. And usually we use these operators to know if an item is available or not available inside the list. So for example, if I say C equal to 1 in list 1. So here I am asking, is the item 1 available in the list 1? And I am going to assign the result to C. So if I run, I will get true. Why true? Because 1 is the first element of list 1. Also, you can ask the opposite question by saying not in. So if I say 1 not in list 1, I'm asking, is the item 1 not available inside list 1? And the result in this case is false. Why false? Because 1 is an item available inside list 1. So you have to know that in and not in are the membership operators to know if one item is available or is not available inside a list. Now let's talk about how we can get access to an individual item inside the list. Let me assume I have the following list: 1, 2, 3, 4, 7, 9, 20. And I want to extract the first item, which is 1 in this case. I can say item equal to list1, 0. And then I will print item. Run, I will get 1. If I put here instead of 1, of 0, 1, I will get 2. So as you see, the first element is in the location 0, the second element in the location 1, and so on. Also, you will note that I use a positive index and it's supported in context of list. Now let's try to extract the element number 9, for example. So how we can do that? We can say 0, 1, 2, 3, 4, 5. So if I put 5 here and run, I will get 9. But in Python, negative indexing is supported, and I can count from the opposite direction by taking negative indexes. So I can say -1, -2, -3, and so on. So if I want 9, I can say just -2 and I will get 9. So I can get access to the same element by using positive indexing or negative indexing in Python. You have to know that indexing is very helpful, not only for accessing to items to get the value, but also I use indexing to update the item value in the data structures that allow update the content, like for example list. So let's say I want to update the value 20 and I want to make it 30. I can say simply list1 equal list1 -1, which means 20, equal to 30, and I print list1 to see what will happen. And as you will see, the last item here is 30, which means the last item has been updated. And this is possible in context of list because list is a mutable data structure. I can do the same thing by using positive index also. So in this case, I have to count how many items I have. 1, 2, 3, 4, 5, 6, 7. So I will put the index 6 here and I will run. And as you see, I get the same result exactly. Another way to update a data structure content, it's by deleting an item from this data structure. And to delete an item from a list, we will use the keyword del. Then I will put list1 and then the index of the item that you want to delete. So for example, if I want to delete 3, so I will say here 2. So I want to delete the item from list1 in the location 2. If I run and I print list1 here, as you see, number 3 disappear from my list. You can delete multiple items if you wish by using slicing. So if I put 0 until 3, this means delete the element 0, 1, and 2. And don't forget that 3 is not included. So if I run, I will get these 3 elements have been deleted and all the remaining are still inside the list. The last idea that I want to talk about in this code session is list slicing. Let me assume that I have the following list. It's named fruits and it has apple, banana, cherry, orange, kiwi, melon, and mango. Now, if I want to extract a sublist from this list, and look what is the difference between index and slicing. If I say item equal to fruits 0 and I print the item itself and I print again the type of that item and I run. Because here I'm just using a single index, this means I want to get access to an individual item from the list and I want to extract that item from the list. So in this case, as I see, I get an apple, which is my item, and its type, it's a string. But when I use slicing like this, if I say from 0 to 2, this means I want to extract a sublist from my list. So if I run, I will get the first 2 items, which are apple and banana, and the type now it's a list. So when I use slicing, I am extracting a list from my list, and keep this in your mind. Also, you have to know that negative indexes is also supported in context of slicing. So I can put -3 until -1, and this will give me this item and this item. And don't forget that the item that you put here is not included. So if I run, I will get kiwi, melon, and the type is list. And that's all for this code session. Now let's recap what we have learned in this lecture. As we see, list is one of the very common data structure in Python, and it represents a sequence of items. In order to define a list, we have to use square bracket, and we see that it's an ordered data structure, it's immutable, it's indexed, and it supports slicing. Now please refer to the file Python lists challenges, in which you will find some exercises to practice what you have learned. Also please refer to the Python lists appendix, in which you will find all the operators in this lecture have been summarized. Thank you very much for your time, and if you are available, join me in the next lecture.